roomQuake is a web-based software application designed for classroom exploration of earthquakes and seismology. In roomQuake, we imagine that our classroom space is a geographic region of high seismic activity. Computers situated around the room serve as virtual seismographs. When simulated earthquakes, roomquakes, occur somewhere in the room, the seismographs respond as if they were actually recording the seismic event. By reading and interpreting the resulting waveforms, students can learn how seismographs can be used to discover where, when, and with what intensity earthquakes happen. Teachers prepare their classrooms for roomquake by positioning computers or tablets in various locations around the room. Because the waveforms that are generated are dependent on those locations, teachers need to carefully measure the dimensions of their classroom and the locations of the computers that will serve as seismographs. roomQuake provides a room configuration tool, shown here on the left, that lets teachers input this information on their personal computers. By launching a browser on each seismographic computer, shown on the right as separate windows, the teacher can specify which seismograph that computer is intended to represent. Once the room has been configured, the teacher can bring the seismographs to life by switching from the planning activity to a waveforms and seismograms activity on their personal devices. Changing to the new activity causes all of the seismographic computers to begin drawing out simulated background noise, the kind one might see on a real seismograph due to low-level ground displacement caused by nearby vehicular traffic. As long as roomQuake is running the waveforms and seismograms activity, the seismographs continue to run. At the same time, in place of the room configuration tool, the teacher now has access to a new tool that allows them to specify the location and magnitude of a new simulated earthquake. Triggering that event signals the seismographic computers, which in turn draw out the waveforms appropriate to their intensity and distance from the simulated quake. This example shows how arrival times and waveform amplitudes depend on the positions of the simulated seismographs, with the P-wave arriving first at seismograph 1, then seismograph 3, and finally at seismograph 2. This collection of software resources can be used to support a variety of instructional activities. One set of activities might focus on the similarities among seismograms obtained at different seismographic stations. For example, the two-phase nature of the waveforms reflecting the multiple ground waves generated by earthquakes, or differences in those waveforms due to their different locations. Provided with tape measures and stopwatches, students could be asked to determine the wavefront velocities by measuring the time and distance between the event and its registration on their seismograph. Having computed the wave velocities, students could then determine the locus of possible event epicenters by drawing out arcs of the appropriate distance from their seismographic stations. The tools presented in this video represent only a fraction of the resources available in the roomQuake software suite. In our next video, we'll introduce more of the roomQuake resources and show how we can use another software application, roomCast, to configure roomQuake resources to support other instructional activities and to adapt these activities to the technology platforms available in different classrooms.